Hi everyone, welcome to the lesson 16.2, Graphing Inequalities in Two Variables Part 1 video. In the lesson 16.1 video, we were introduced to graphing inequalities in two variables. And in this video, I'm going to give you a step-by-step list to graph any inequality in two variables. So step 1. We are going to graph the given inequality like we were graphing an equation. So we are going to pretend that this is y equals 2x plus 3 and plot the correct points. So 3 is my y-intercept, so that will be my first point. And remember, when we are given a whole number slope, we can put a 1 in the denominator. So this will tell us we go up 2 and to the right 1. So up 2 to the right 1, and up 2 and to the right 1. Or we can go backwards by flipping both directions. So instead of going up and to the right, we can go down 2 and to the left 1. Down 2 to the left 1. And the more points you have, the better, because it will help make your line nice and straight. So now that all of my points are plotted, the next step is to determine if the boundary line is solid or dashed. This is very similar to when we graphed inequalities on a number line and had to determine if we should use an open circle or a closed circle. If there is a line under our inequality sign, we will have a solid boundary line because the line indicates equal to, and by having a solid line, it indicates that any points on the boundary line are solutions to the inequality, similar to having a closed circle. But if our inequality sign does not have a line underneath it, our boundary line will be dashed. And that tells us that we cannot have points on the boundary line as solutions because the inequality sign tells us that our values either have to be greater than or less than the points on the boundary line. So if your boundary line is dashed, it tells you that any points on the boundary line are not solutions to the inequality, similar to having an open circle. So if you look up at our inequality sign, I do have a line underneath it, which means equal to. So my boundary line is going to be solid all the way through my points. And our final step we have to determine which side of our boundary line we are going to shade. So we have to determine where are the solutions to our inequality. Are they above the line or below the line? One way to do this is by plugging in a point to test. I always like to test the point 0, 0 because 0 is a very nice number to plug in. So if I plug in the point 0, 0 to our inequality, it would look like 0 is less than or equal to 2 times 0 plus 3. So I plugged in 0 to x and y. 2 times 0 is 0, and 0 plus 3 is 3. Once I reach my final statement, I have to determine if it's true or false. Because 0 is less than or equal to 3, this statement is true, which means 0, 0 is a solution to the inequality. And since 0, 0 is a solution, it has to be on the side that I shade, because my shading indicates where the solutions are, And if 0, 0 is a solution, it has to be on the side that I shade. We can also see that our inequality reads that y has to be less than or equal to, and I know that my y values are less or smaller underneath the line. And so if it says y is less than, that tells me that my shading will go below the line. Before we try some more examples, I have 2 vocabulary words for you: a closed half plane and an open half plane. A closed half plane includes points on the boundary line as solutions. So this is when I have a solid boundary line, and any points on the boundary line will be solutions to the inequality. But an open half plane does not include points on the boundary line as solutions, and that's when I have a dashed boundary line. If I have a dashed boundary line, the points on the boundary line are not solutions to the inequality. So let's try a couple more examples. My first step is to plot my points like if I were graphing an equation. So my first point will be at -4, which is my y-intercept, and my slope is 1/3, which tells me I'm going to go up 1 and to the right 3. So up 1 to the right 3, up 1 to the right 3, or to go backwards, I can go down and to the left. So down 1 to the left 3, down 1 to the left 3. My second step is to determine if my boundary line is going to be solid or dashed. If I look at my inequality, because there is no line underneath, it's telling me my boundary line will be dashed. So instead of filling in the line completely, I'm just going to put little small tick marks. And my last step, I have to determine which side of my boundary line the shading goes on. So I'm going to plug in the point 0, 0 and see if it works. So plugging in 0 for x and y. 1/3 times 0 is 0. And 0 minus 4 is -4. And 0 is greater than -4. So this is a true statement, which means 0, 0 is a solution to the inequality. So that means that the side that 0, 0 is on needs to be shaded because 0, 0 is a solution and it needs to be part of the shaded region. I also could have determined this by looking at the way the sign is facing. And because it's saying that y has to be bigger than the boundary line, I know that the bigger y values are above the line. And so that would indicate that I need to shade above the line. I would like you to try this one on your own. So if you can pause the video and try this one on your own, and then unpause the video to check your answer with mine. Welcome back. I hope that you paused the video and gave this one a try before looking at my answer. I am going to start by plotting my points. So 3 is my y-intercept, so that will be my first point. And because -5/2 is my slope, it tells me that I'm going to go down 5 and to the right 2. So I'm going to go down 5 to the right 2, down 5 and to the right 2. I now have to determine if my line is going to be dashed or solid. And because there is a line under my inequality sign, this tells me that my boundary line will be solid. So I'm going to draw a solid line through these points. And lastly, I have to figure out my shading. So because this says that y is less than, I need to find where the smaller y values are. And I know that the smaller y values are below the line. So if the sign is facing towards the y, this says shade above the line. But if the sign is facing away from y, this is saying that y needs to be less than the boundary line, so we are going to shade below the line. Or if you would prefer to test a point, that works too. If you plug in the point 0, 0, -5/2 times 0 is 0, and 0 plus 3 is 3, and 0 is less than or equal to 3. So 0 is a solution, and you'll notice that I did shade the side that 0, 0 is on. So either way that you want to determine the shading works. I just find that this method of looking at how the sign is facing is a little faster. But if it makes more sense for you to test a point, please go ahead and continue to do so. I hope that you'll continue to use that step-by-step list when graphing linear inequalities. And in the next video, we are going to see how to graph inequalities when the form of the inequality is standard form. So if you need help rewriting inequalities into slope-intercept form, make sure you watch the next video. Please let me know if you have any questions in class, and I will see you later.